Okay, Saxon 4 Math students, we're ready for lesson 75. We're going to be talking about measuring turns. Okay, so we're going to go straight to some examples. And before we get into example 1, let's talk about some turns that you're familiar with. Okay, let's say that you're in a basketball game and you're going to do a really fancy dunk and you want to turn all the way around and then make your dunk. Okay? Let me draw my little basketball net here. If you do that entire turn and then dunk it, that has a special name. It's called a 360. And it means that you've turned 360 degrees all the way around. Okay? And you see that it's a full circle. You start out facing one direction, you totally turn around, you're facing that same direction, but you've made a complete turn, a 360. Okay? Now think about the cha-cha slide and the part where it says reverse, reverse. And when it says reverse, let's say if you were here and you were facing this direction, a reverse would be to face completely the opposite direction. And so each time you would be turning halfway around, okay? And so what we would do, if there are 360 degrees in a full turn, then what would half a turn be? And it's like this. You take that 360. If you divide it in half, that's dividing by 2. How many groups of 2 can I get out of 3? 1. 1 times 2 is 2. Subtract. Bring down. Now how many groups of 2 can I get out of 16? 8. Because 8 times 2 is 16. Subtract. Bring down. How many groups of 2 can I get out of 0? 0. And 0 times 2 is 0. And we know we're finished. There's nothing left to bring down. So look, halfway around, that's a 180 degree turn. Okay? So we know what a complete turn is. All the way around is 360. Halfway around is 180. So let's keep going. You can also do, just like a clock has, you know, quarter after, quarter till. Well, you can do quarter turns, okay? And you may use this in dance class or just in giving directions, okay? Maybe you have a treasure map and the instructions say to do a quarter turn to the west, okay? Or you're facing west, then make a quarter turn to the left. You've got to be able to follow those directions. So now if you change colors, if halfway around is 180, what I want to do next is find out what that quarter turn would be. If I just went from here as my starting point and stopped here, that would be 1/4 of the way around, right? That's why I'm saying 1/4. It's 1/4 of the way around. So we would take the 180, the distance you see in red here, and I want to split it in half. So let's do that. 180 divided into 2, and that means in half. How many groups of 2 can I get out of 1? I can't. How many groups of 2 can I get out of 18? 9, because 9 times 2 is 18. Subtract, bring down. How many groups of 2 can I get out of 0? 0. And 0 times 2 is 0. And so a quarter turn is 90 degrees. Now what's so cool is that in that 90-degree turn, if you trace the angle, you see a right angle. And they say a right angle is a 90-degree angle. That's really cool. So how many 90-degree turns would you have to do to make it all the way around? Well, 1, 2, 3, 4. So now you have the background and we're ready to start. Maria and Arena were both facing north. Okay. Maria turned 90 degrees clockwise. Now when it says clockwise, it means just like a clock would turn. So if she's facing this way, a clock's hands go to the right, don't they? So a 90 degrees clockwise would have Maria turning just like this and facing what direction? East. Okay. Now let's take a look at what Arena did. She was also facing north, but she turned 270 degrees counterclockwise. Now, counterclockwise means opposite of clockwise, so that is to the left. Now, think of your 9 multiplication facts. Okay, 9 times 2 is 18. Okay, that'd be 2 hops around, that'd be 180 degrees. But if we took a third hop around, a third of a 3/4 turns, think 3 times 9 is 27. Okay, so if Arena is facing north and she goes counterclockwise 270 degrees, we're going to count them: 90, 180, 270. She's also facing east, right? How cool. It says after turning, in which directions were the girls facing? Below we show the turns Maria and Arena made. Here's Maria's. She was facing north, 90 degrees clockwise. Now she's facing east. Arena, look, she went counterclockwise, 90, 180, 270 degrees, and they end up facing the same way, east. Cool beans. Okay, now example 2. More about turns, but we're going to start measuring them. And we did, transformations recently, and you were to imagine pattern blocks and turning them. And we did flips and slides also, but today we're turns, we're thinking about rotations, okay? Describe the amount and direction of a turn around point A that would position triangle 2 on triangle 1. So it's like if you had this triangle, how could you rotate it? How far? How far and what direction? So let's take a look at my next little slide here. And I so wish that I could rotate around a point with my shapes, but I can't. We're going to have to imagine it. I can rotate them, but it's not on the point that I want to. So if we take, you can imagine, this point right here, this point right here, and if I slide this point to this point, you can kind of see how far that is, can't you? It's not directly opposite. That would be way up here, okay? So let's think about it. This is like 1/4 the way around an entire circle, isn't it? And we know that just 1/4, that is not a 90-degree turn. Now, was that from here to here? Look at my arrow. Was that counterclockwise or clockwise? It looks like the clock would be going backwards, so we say counterclockwise. So that's what we would need to do to triangle 2 to make it be positioned totally on top of triangle 1. You have to be really good at visualizing things. Okay. The other way you could do it is to go totally around from here. Let me change colors. All the way to here. And you can see that that is how many quarters? There's 1, 2, 3. So 90, 90, 90, 3 times 90, that would be 270 degrees. And that would be going in the same directions the hands of a clock would be going in. So that would be 270 degrees clockwise. Okay, lesson practice. Waukesha skated east. Okay, let's draw this out. North, south, west, east. Okay, Waukesha, she's skating toward the east. Okay, imagine that. Turned 180 degrees clockwise. So we know a 180-degree turn, that's halfway around, and she was going in the same direction that clock hands would go. So that would be this way. That's 180 degrees. Okay. In what direction was Waukesha skating after the turn? And you can see that she was skating toward the west. Okay, now describe each rotation in degrees, clockwise or counterclockwise. Okay, a quarter turn to the left. Well, we know a quarter of the way around, that's a 90-degree turn, and to the left. Imagine clock hands going to the left. Is that the right direction? No, so that's counterclockwise. 90 degrees counterclockwise. A full turn, that means all the way around. A full 360, right? To the right. Imagine clock hands moving to the right. Is that in the right direction? Yes, it is. So 360 degrees clockwise. Okay, how about D? A 3/4 turn to the left. Okay, that's like 3 of those quarters, so it'd be 3 times 90, which is 270. Now imagine your clock hands moving to the left. That is counterclockwise, isn't it? 270 degrees counterclockwise. Okay, how about a half turn to the right? Well, halfway around is like in the completely opposite direction. That's a 180 when you do a reverse, okay? And to the right, imagine your clock hands going to the right, and that's clockwise, so 180 degrees clockwise. Okay, describe the rotation that would position triangle 1 on triangle 2. And I tried to draw this, and we want 1 to be on top of 2. And so imagine, it helps if you draw the points. We want this point all the way over here to this point. Look how far away around that is. That's halfway around. So that's 180 degrees. Now what if my clock hands went in this direction? Is that the same direction as a clock? No, it's not. So that would be counterclockwise. And if we did that, we would have a perfect match. Okay, 180 degrees clockwise. They said or counterclockwise. Let me take a look. Yeah, we could have gone in this direction as well, and that would have been like the hands on a clock. Totally opposite. I think when you do a 180, you have a choice to go like the clock or in the reverse of a clock. Okay, now let's go back and check your 74 written practice. So hit pause as you check 1 through 9. Hit pause as you check 10 through 18. And hit pause as you check 19 through 30. Okay, now we're going to do some mental math. Make sure if I'm on the right one. Okay, this is teaching you a new little trick today. It says the sum of 38 and 17 is 55. If we make 38 larger by 2 and 17 smaller by 2, then this is the same addition as 40 plus 15, which is really easy, isn't it, to do mentally. The sum is still 55, but mental addition is easier. So before finding the following sums, make one number larger and the other smaller so that one of the numbers ends in 0. Okay. For this one, I'm going to bump this up to 40, and that's bumping it up by 2, isn't it? What if I make this one go down by 2? This one would be 40, and this one would be 25. And now it's easy to add. 65. Let's make this one go up 2 to 50, down 2 to 22. So 50 plus 22. 72. Okay, let's go up 1 to 60 and down 1 to 31. 60 plus 31, 91. Okay, let's do 57, up 3 to 60. Now let's go down 3 over here. 60 plus 23, 83. Okay, for money, let's pretend that this one is $3, and we will take off a penny when we're done. So add $3 on, and now take away a penny, and you've got $9.48. How many cups is 1 pint? Well, I imagine, drawing one of my people in the gallon house. One of my people looking out the window, and I know each little person has 2 eyes, okay? 2 cups, and that's the answer. 2 cups. Choose the more reasonable estimate for the temperature inside a refrigerator, 3 degrees Celsius or 30 degrees Celsius. And remember, we're in Celsius, so the freezing point for Celsius is 0. Now, 3 degrees is a little bit above freezing, so your things will get really cold without freezing. Now, 30 degrees Celsius, that's pretty warm. I don't know about you, but I want things inside my refrigerator to be nice and cold, and 30 degrees Celsius is not cold. Okay, calculation, 2 times 9, 18. Now, plus 29, let's treat it as plus 30. So 18 plus 30, 48, take away 1, 47. And now I immediately see the 7 and the 3 makes 10, and then the 40 and the 50 is 90. So 90 and 10 is 100, and 100 divided by 10 is 10. All right, let's take a look at problem solving. Sid wants to know the circumference of, that means distance around, and the trunk of the big oak tree at the park. Now this word circumference has to do with circles, okay? You can actually see CIRC if I cover that up or just look at that part. It almost looks like I'm getting ready to spell the word circle. So circumference means all the way around the circle. Okay, so this means all the way around the trunk of the big oak tree. He knows the circumference of the tree is more than 1 yard. Somebody must have told him, I don't know. Sid has some string and a yardstick. How can he measure the circumference of the trunk of the trees in inches? Aha, he's got some string, which will bend, right? Yardsticks don't bend. He can take the string and go all the way around the trunk of the tree and measure it. He could even cut it off if he needed to. And then he needs to measure the string with the yardstick, right? And even though he knows it's longer than a yard, he can mark the point that it reaches the yard. And then he can start using that yardstick again and just add those distances together. Okay? And so the total will be the circumference of the trunk. Okay, now let's do our power up, and your job is to think of the answers faster than I can write them. Are you beating me? And there we have it. I hope that your brain was faster than my pen pad today.